Well, how are you doing? Okay, the title of this video will be 69.04 horizontal miles. Um, we deal a lot with our opposition trying to claim that 60 nautical miles per degree has some relevance to a spherical globe Earth, when it has absolutely nothing to do with that. It's been hijacked by the globe because the globe was created via flat Earth elevation angles to Polaris, because that's where the latitude and longitude grid comes from. Now, it's very easy to disprove their claims, right? Not only are elevation angles obviously not going to work on the surface of a globe, but there's more than that. It's more simple than even than that. And I'm going to go through it, okay? So here we have your basic diagram of an elevation angle to Polaris, right? Now, what they needed to know was how far back away from Polaris, or let's say move towards Polaris, to get 1 degree of change, of angular change, what distance was that? So 1 degree of angular change ended up being 69.04 statute miles, right? So what did that mean? That means that they moved either towards Polaris or away from Polaris enough times to make sure that they got 1 degree of change, and that 1 degree of change always came out to exactly 69.04 statute miles. Now, obviously, they would have put in the past, before that, they would have done this with stadia, whatever, other measure, back in the Greek times, whatever. Whatever they would have used, whatever ratios they used back then. Or unit of measure, I should say, they used back then. But we use these days statute miles, right? So they needed to find out what 1 degree of change was in statute miles. They didn't have nautical miles. Now, that's not technically true that the nautical mile didn't exist, but didn't exist as we know it today, because there is measurements. If you go the full perimeter of the Giza pyramid, that's exactly 1 nautical mile. I can't remember the name of the unit of measure that the Egyptians had. It was half of a nautical mile. So the full perimeter of the Giza pyramid is two of their units. I can't remember the name of the unit now. It won't come to mind. But it's the perimeter of the Giza pyramid is two of these units of measure, and one of those units of measure was exactly half a nautical mile, right? Which means it was technically half of a degree, right? If you want to see it that way, or half of a degree, right? Or sorry, half of a minute, right? So it'd be 30 seconds, sorry, half of a minute, and because 1 nautical mile is 1 minute, right, of the Greek. So around the Giza pyramid, you have 1 minute in length, right, in straight length, going 4 different directions. You have exactly 1 minute length, one nautical mile, which would be equivalent to 1 minute of change, angular change, to the celestials, let's just say, right? That's just a little bit of history. So the point is that the knowledge of what we call a nautical mile and its correspondence, let's say minutes of degree or seconds of degree, and their correspondence onto, like, say, either transference or correspondence onto the Earth's surface, that was known before our times. But we use statute miles and nautical miles. That's what we use, right? They might have called it different things in the past, like stadia, and I can't remember the name they had on these units of measure in Egypt, right? But the point is, they did know about these things, just called them different names. And the unit might have been a little bit different, the unit of measure, but it doesn't matter. It was the same thing, right? So to get an angular change, they needed to use a sextant, right? That's what was used in, let's say, our times, or an astrolabe or something, right? So they're using this to get an angular change. They're using an elevation angle to get 1 minute of change, and then decipher what exactly that 1 minute was, right, in statute miles, right? So here we have the celestial sphere, they call it, but it's really only a celestial dome, because we have the observer here in the center, that's north. You have azimuth around, right? This is all horizontal, what's known as the horizontal coordinate system. Azimuth around to the GP of the celestial body. And the celestial body is in an apparent position based off of the observer looking straight at it in their perspective view. So the observer is not seeing what we're seeing here. The observer is just seeing everything in a perspective view, not in an orthographic view. So when you try and show this angular change matching feet and inches, feet, and miles orthographically, it doesn't work across a horizontal plane. The reason it doesn't work is because it's purely an angular relationship. It's a perspective relationship. It has nothing to do with orthographic. It's got to do. This is where the protractor comes from, right? It's based off the protractor is based off of perspective. That's what it's based off of. I don't know what the celestials are. I don't know what height they are. I don't need to know their height. This is the difference. Is what our opposition don't understand. To gain the knowledge they needed for what a nautical mile was, they didn't need to know the height of the celestial body. They don't need to know that. They just need to know the distance, right? 1 nautical mile of distance is 1 minute of change, right? A degree of 1 minute, right? Tells them how many. So 1 degree of change. 1 degree of change would be 69.04 statute miles, right? That's what it is, right? That's what they needed to know. Before they could ever start asserting what a nautical mile was, they needed to know what the angular change was in statute miles. So this is the celestial dome, the part of the sky that is visible above natural obstructions, right? That's what you can see, right? It's your dome of the heavens. The sky is not a dome, right? The sky is actually, the best you could call it would be another horizontal plane above the earth we stand upon. The sky is just, our vision works that way, okay? So here we have it again, the horizon, zenith, your celestial dome, right? It's purely perspective based. It doesn't mean that the stars are actually going down or coming up or anything else. It just means that that's how you view them. This is how we view them. It's our natural way of viewing them. It's perspective. Now, here we have from timeanddate.com showing that this is the horizontal coordinate system. This is how we see. This is our zenith, 60 degrees, 30 degrees, 0 degrees. This is an orthographic, but it's showing an orthographic. The best way to represent this orthographically is via a circle, because it shows that change, right? Now you don't need to. You can actually use. You don't need to use a circle for this, but it's you can use a triangle for it, but it doesn't matter because it's the same thing where it's showing the change. It's an angular change. Angular measurement is perspective measurement. That's what it is, right? So if we go on, so an inch, right? What is an inch? A unit of linear measure, right? Equal to 1/12 of a foot. So an inch is a linear measurement, right? Right. Linear is straight line. So linear foot means a unit of measurement in a straight line on a horizontal plane. That's what a foot is. So an inch is a straight line, and 12 of them creates a foot, and a foot is a straight line. Technically, a linear foot is a measurement that is 12 inches long, so 1 foot. That is measured in a straight line, which is why it's called linear, right? So that's all pretty straightforward. So inches and feet inches of feet are straight lines. Okay, the mile, right? Sometimes the international mile or statute mile, to distinguish it from other miles, is a British imperial unit and United States customary unit of distance. Both are based on the older English unit of length, equal to 5,280 English feet, right, or 1,760 yards. So if there's 5,280 feet, which is, and feet are linear, right, that means there's 5,280 linear, right, distances making up one big linear straight line distance, right? The statute mile is a horizontal. It's a horizontal distance measurement. That's what it is. It's a straight line measurement. That's what it is, right? Inches are straight line measurements, feet are straight line measurements, and miles, statute miles, are straight line measurements. Okay, so 1 mile, which is one statute mile, is 5,280 feet, right? So and 1 nautical mile is 6,076.12 feet. That's 6,076.12 linear feet, linear distances end to end, making up 1 nautical mile. That's what it is. So a nautical mile, right, it has a feet distance, right, a foot length, right, because it's one straight line. That's what a nautical mile is. So what did they do? So 1 second, let's get the calculator out, right? So we'll just 69.04. So 69.04 statute miles, right? So what they did is they figured out that in a horizontal straight line, right, using landmarks took a bit of deciphering, and our 10th man has read out on the flat earth debates. He's read out, right, historical information concerning this. They had to find out what a statute mile was, right? Well, how many statute miles, was in 1 degree of angular change, right? And they found out there was 69.04 exactly statute miles in 1 degree of angular change. That's 69.04 straight line distances, all matched end to end, right? So that means it's a straight line, right? So what did they do then once they had 69.04, right? They needed to find out then, okay, whereas 60 minutes of degree, right, in every 1 degree. If there's 69.04 straight line miles in 1 degree of angular change, then that means that if we divide this by 60, right, we'll get 1.1506666. The actual amount is 1.1508, which I'm going to show in a minute. So they figured out that there was that by dividing 69.04 by 60, right, there was going to be 1.1508. It's actually 08 is the correct amount. 1.1508 nautical statute miles in 1 nautical mile. That means there's 1.1508 straight line miles in 1 nautical mile, which is also a straight line mile because it has to have a foot, right, a feet and inches measurement distance, right? So that's what they did, right? So miles are units of length measuring 5,280 feet or 8 furlongs, commonly used in the United States and Great Britain. A statute mile is a name given to the definitive measurement used in Britain and America, where the miles referred to on road signs or maps, for example, are statute miles. Nautical miles are used to measure the distance travelled through the water. This is from National Ocean Service. Nautical miles are used to measure the distance travelled through the water. A nautical mile is slightly longer than a mile on land, equaling 1.1508, as I told you, land measured or statute miles. Land measured, statute miles. The nautical mile is based on the Earth's longitude and latitude coordinates, with 1 nautical mile equaling 1 minute of latitude, 1 minute of degree, right? So the whole thing, right, is horizontal measurements, right? There is no curved nautical mile. The nautical mile is an extension of the statute mile, which is a straight line distance. So if there's 69.04 statute miles in one degree of angular change, right, that means there's 60 straight line horizontal miles, right? 60 straight line horizontal nautical miles in 1 degree of angular change, right? It's all measured horizontally. Nobody measured a nautical mile as an arc. Absolutely nobody. And they never will, because we don't have a globe Earth. We don't have an arced Earth. We have an Earth that has a mean sea level that all elevations are taken from, right, and matched to, right? That is a horizontal line straight through the Earth. That's what it is. That's where we get our horizontal from. Okay, UNCLOS, right? Maritime and airspace zones. So you have here 12 nautical miles, 24 nautical miles, 200 nautical miles. They're all straight line, right? All shown in the diagram as straight lines. Why did they show them as that? Because they're just trying to show a diagram, but they're making it to what it really is, which is straight lines. You have international airspace, straight lines. National airspace, straight lines. Exclusive economic zone, 200 nautical, straight miles. It's a straight line, always a straight line. Here is more, right? UNCLOS, maritime zones, right? 12 nautical miles, 24 nautical miles, 200 nautical miles, right? The sea level is a horizontal. No matter, you know what I mean? There is no, they know, they're just like, until they start thinking, oh no, I better start claiming it's a globe, other than that, they're just dealing with a flat plane. They're always dealing with a flat plane. A nautical mile is a straight line distance. A statute mile is a straight line distance, and a nautical mile is just 1.1508 of those straight line statute miles. Statute miles is a measured mile. It's measured on the earth as a straight line, right? It's a straight line horizontal measurement. So 69.04 of those straight line horizontal measurements makes up 1 degree of angular change. 1 degree is 60 minutes, right? And to convert those 60 minutes, you've got to divide that 69.04 straight statute miles, horizontal statute miles, into 60 horizontal nautical miles. There is no nautical miles connected to a globe. That's complete and utter rubbish. There is no globe. Right? This is the proof. How we measure things proves it. Here we have again another one showing again straight lines, always straight lines. There's our nautical miles and they're dealing with straight lines. Why do they show them as straight lines in the diagrams? Because that's what they really are. They're straight lines. They're just a conversion from the statute mile measurement, so they can display them as minutes of degree, which are just perspective based. That's all minutes of degree is, and that's what it is. That's where your celestial dome comes from. Minutes of degree, this perspective view, the protractor view. That's all it is. There's no actual curve to this going. It's just the way we view it. Do you know what I mean? It's just the way it's viewed. That's it. It's our eyesight. Here you have someone. This is the measurement of nautical charts. These I can't remember the particular name of these compasses. But they're a maritime compass, and they're probably used in aerospace as well, to measure straight line distances. So they're measuring minutes of latitude as nautical miles, but they're using charts, and I don't care what projections they're using. I don't care if it's universal, transverse, Mercator. I know that's based on a globe. It doesn't matter. The point is that in reality, every chart, they're doing all their distances, they're working them out on maps. They're not using, like you will see with people on our opposing side, showing plastic globes and them drawing on it. Nobody is doing that. Only crazy people on our opposing side are doing these crazy things. In reality, people are using maps, right? Charts and maps, and they're dealing with straight line distances. They're measuring straight line distances, and they're going to be measuring nautical miles as straight lines, right? Here we have it again, right? They're measuring straight line distances. They're measuring nautical miles here as straight line distances, right? Here we are again, this lady here is measuring, right, nautical miles as straight line distances. That's what she's doing. She's even got this maritime particular type of ruler here. That's specifically for it. I can't remember the name of it now. But like, she's using charts and maps. They don't have one big world map or one big plastic globe. I've had people on our opposing side trying to tell me that they bring a big blow-up plastic globe out to sea with them and they draw circles on it. No, they do not. This is what they do. They have charts and maps. That's what they have. And they draw straight line distances and deal with straight line distances. They don't have one big world map. They don't do that. These are all sectional little maps that they deal with straight line distances on. That's what they do. They're not drawing circles on plastic globes. Here you have it again, right? Here you have 3.2 nautical miles, right, measured with the compass, right, and that's 3.2 minutes of latitude. So 3.2 minutes of latitude, 3.2 nautical miles. Straight lines. That's what it is. It's not some other nonsense. There's no arcs, there's no globes. It's a straight line measurement because it's a conversion from statute miles, which are straight line measurements. So they took 69, they found out that they had 69.04 statute miles for every 1 minute, for every 1 degree of angular change. And they just divided it by 60. That's all they did to come up with a ratio of 1.1508, right, statute miles per 1 nautical mile. That's it. It's that simple. There's no globe, no curve, no arcs. No one's drawing circles on blow-up globes out in the middle of the Atlantic. That's not happening, crazy people. You're crazy if you're thinking that. If that's what you think, you're crazy. You're crazy. You need to really sit down and have a real word with yourself. You're crazy if you think they're doing that. Nobody is doing that. I know people who have sailed. Nobody's bringing plastic globes out to sea with them. It's crazy. You're crazy. You're just crazy people. I'm sorry. Crazy. You're all crazy. Anyway, that's the end of the video. Just wanted to dispel that ridiculous myth that our opposition keep on trying to attack us with. It's just a hijacking of reality, like they always do. So all they're ever good for is trying to hijack reality and keep it for themselves. Because they need to hijack it, because they're trying to live in, they need reality, right? They need to hijack reality to allow themselves to live in their fantasy. It's mad. It's crazy. Thanks for watching.